Hey Professor, this is our Physics 114 project. So on to the questions from pages 1. So what is the consequence of preventing thread slippage against the eye bolt? It's so the string doesn't flow freely from the bullseye and mess with the data in the y-axis. What is the pivot point of the pendulum? The pivot point is the eye bolt because as the definition of a pivot point is the point where something balances. In our case, we're balancing the ball in the string. And explain how you use the paper ruler to determine the pendulum release angle. You take the inverse tangent of the distance from the ruler to the block and the distance from the middle of the ruler to where we are going to start the string at.
Um, the second page is question number 4. What is the benefit, if any, of putting the paper ruler further down? We thought the benefits were larger numbers to work with so we can easily set up the experiment to take the answers from. Question number 5 is what is the uncertainty of your measurements in question step 4? We thought we were pretty sure about our measurements, so we said around 0.01. Um, yeah.
And why is the scale factor necessary? It's because if you don't have a scale factor, your points on logger pro would read very high numbers. Having a scale factor would help it become more precise. And what length might you choose to establish the scale factor for our data? The string was meter as a good scale factor because what we did was we measured how we so first on the pendulum or on the wood block we tied it around, and then after that we let down the ball or the metal ball, and then from that we hand measured how long 1 meter would be for the string.
Question number 8, we said you asked us to draw a free body diagram, and we did this. A picture uploaded. We also did the angle, how to find the angle, and our measurements of the 20 centimeters from the angle from the block and the 5.4 centimeters from the angle where we pushed it to, and that would equal 15 degrees. Question number 9 asked us to write the Newton number 2 of how to find the question number 8. We said the answer would be F equals ma.
And then for use Q9 to solve for the tension in thread, we found 0.76 newtons by using the tension equation. And based on Q10, at what angular position do you expect the thread tension to be the greatest? The angular position we would expect for the thread tension to be the greatest is the bottom, because the kinetic energy is greatest, since the gravitational potential energy is smallest because it's at the lowest angle.
Question number 12, use connections of mechanical energy to find the speed of the ball and the lowest point. Assume the initial angle of the vertical angle from vertical. We found this to be 4.43 meters per second using the mechanical energy theorem equation. Question 13 is what is the speed of the ball at its highest point? Explain it. And we thought this answer would be 0 meters per second because this is where we started from, and the momentum and speed of the ball is 0 because technically right when we release it is not moving.
And then explain how logger pro finds x velocity and y velocity given x position and y position as a function of time. Our answer is logger pro takes the change of position over the change of time with 2 points, then repeats the process. Q15 is explain how you use logger pro to calculate speed. We highlighted a certain amount of points and clicked the icon above that looks like a linear position to have logger pro find the speed. V equals square root 2 times negative mg, 1 minus cosine theta divided by n.
Question 16, explain what you did in the previous question. We explained this by using the equation rearranged to find v, and v equals square root 2 minus negative mg parentheses 1 minus cosine theta all over the mass. Question 17, explain how to use a logger pro to calculate the centripetal acceleration. We used the equation given AC equals V squared over R. This numbers could be found in the equation.
And estimate the percent error in our determination of tension in the string at the lowest point of the ball. So we got 22.44% by having So we had 22.44% by doing 9.8 divided by the 4.43, which is the experimental, and then the accepted divided by the experimental. And so then we multiply that by 10, we got 22.44%. And the Q19 is the experiment is done on the Earth's moon. What is the value of the thread tension at the lowest point? So what we did was we looked up moon's gravity, and then we plugged it into the tension equation. And so then we had our value of 0.047328 newtons, because the gravitational pull is not as strong as Earth, so the tension at the lowest point wouldn't be as much compared to Earth's.
For question 20, we said this equation is done on the Earth, but an elevator accelerating straight up at 5 Gs. What is the thread tension on this ball in the lowest point, assuming the release angle is the same? We calculated this to be 4.17 by taking the 9.8 in the equation and timesing it, multiplying it by 5.
Yeah.
And basically doing the same thing we did in the previous question, where we found the release tension, string tension with the normal gravity. This was all our presentation we done on this experiment. Explaining more overall would be this experiment took careful precision of the angles that we measured and released many trials to release it at the right angle.
Yeah.
Overall, taking the video and uploading it to LoggerPro and taking the numbers and plugging them into various equations was very educational and very thought-provoking.
Yeah. For the videos, it took us about 3 tries, just because we found it more effective if we used the protractor and taped it under the pivot pole. So then we were able to find out where the 15 degrees would be. So then we took it from 90 minus 15, which would be 75, and then that's where we had the ball and the string pulled at. So then that's how we were able. Most of our measurements were handmade, or not handmade, but we were doing it by hand. So, and that is our presentation.
Thank you.